My name is Abbie Robinson, and again, I'm a master's student at Pennsylvania State University. And today I will be presenting on a project I completed with two of my collaborators on climate variability and internal migration in Asia. So, just to go over some presentation goals, first with our research objective is to examine how exposures to temperature and precipitation variability affect internal migration across 6 countries of interest. I will proceed with explaining our methods and how we test for non-linearities in and interactions between climate effects, followed by explaining our key results and how we evaluate variation and effects by subpopulations, by distance, and reason for migration, which I will provide more details in the upcoming slides. And 3 of our main findings, which include first, that migration declines during periods of below average precipitation. Secondly, how precipitation deficits reduce short and long distance moves. And thirdly, how climate exposures are significant predictors of work-related migration. So our motivation for this study, we all know that climate and migration is a huge topic, and studies have found that there are increases, decreases, or even null effects on the relation between climate variability and migration. And with all of these studies, the results vary with the use of non-comparable analytic measures and methods, which makes it quite difficult to compare findings between these studies. And there's also limited research on cross-national differences and being able to compare a group of countries and seeing how climate variation impacts migration and additional types of migration, whether it's international migration or in this case, the focus of our paper, internal migration. And with these gaps, we apply a big data approach with the use of harmonization of survey microdata for multiple countries with consistent methods to assess the relation between climate variability and internal migration. So our study area is 6 countries in Southeast Asia, which are indicated in the lighter shades of gray here. So China, Indonesia, Malaysia, Nepal, the Philippines, and Vietnam. And this is a super important area that we should pay attention to, as it is home to about a quarter of the world's population and is extremely vulnerable to environmental change. So getting into our data, we draw our demographic data from IPMS International, where we acquire census and survey microdata that meet the following requirements. First, it's a survey collected in Asia. Second, it has a harmonized geographic identifier for place of residence in reference to 5 years prior, which I will explain the significance of that variable. And each country has at least 2 rounds of data between our year sample range, which is from 1985 to 2011. And with these requirements, we are able to have a data set that includes over 54 million observations from individuals of these 6 countries within the age range of 15 to 49 years. Because we're focusing on internal migration, we exclude individuals that reported living abroad or in an unknown location during our study years. And with this demographic data, we merge it to our climate data, which we draw from the Climatic Research Unit, or CREW, which provides monthly high-resolution temperature and precipitation estimates and provide provincial-level spatial means. And with this data, we are able to evaluate our measures. Our first binary outcome is interprovincial migration, where we apply that 5-year migration interval. So for instance, if we have a survey from the year 2000, we are able to identify that individual's place of residence. We refer 5 years back to 1995, and again, we look at that person's location of residence. If those 2 locations if those 2 locations are the same, that indicates that there was actual migration. We also look at migration by distance. So we're interested in short and long distance moves. So we compare an adjacent move to a neighboring province or a long distance move, which we indicate as non-adjacent. We also look at migration by cause, which we code into 3 categories: educational related move, so perhaps moving to a university opportunity for higher education, a family-related move, whether it's related to marriage or something in connection to a spouse, or a work-related move, perhaps moving for a job. Our predictors of interest are temperature and precipitation anomalies, which are operationalized as z-scores with a range of 2 standard deviations below and 2 standard deviations above average precipitation or temperature. Our controls include age, sex, and educational attainment, which are provided for all of our observants. We apply province and decade fixed effects to a series of models where we run binary and multinomial logistic regressions to assess our results. So looking at our first binary migration model, this first graph is showing the relationship between precipitation anomalies and migration, and we are able to generate, first we make sure to hold all variables at their means, and then we're able to generate predicted probabilities of interprovincial migration across a range of climate exposure values. So this graph is showing precipitation anomalies. Oh, maybe I don't know how to use this. The top? Well, this is 0 in the middle on the x-axis. That is showing our average precipitation, followed by 2 standard deviations below, so below average precipitation. And then over here is our 2 standard deviations above, so higher rainfall than a normal year. And this graph, with this steep decline with the below average precipitation, is showing that migration actually reduces during precipitation deficits, and below average precipitation is a more meaningful predictor of migration behavior and patterns in comparison to above average precipitation. So now moving on to migration by distance, which is the short versus long distance moves. Our adjacent moves are depicted here in comparison to non-adjacent moves. If you can refer back to the first graph I just showed you, the adjacent moves, the short distance moves, depict a very similar story, and showing that reductions in precipitation, below average precipitation, is actually keeping people in place and reducing migration. If we are just comparing these two graphs, they actually are very similar. We don't find any significantly large differences in climate effects based on difference. The only thing that we can see is that non-adjacent moves appear, for precipitation exposures, appear to be generally weaker and more linear compared to adjacent moves. And again, these two graphs are showing precipitation anomalies, and the reason why I'm not showing anything on temperature is that we find that temperature effects are not a significant predictor of migration by distance. Now, for migration by cause, this analysis only allowed us to draw results from a subset of samples, which included China, Indonesia, and Nepal. And that is because these surveys had very detailed information where they asked the observants a specific question as to why they moved, which we categorized into the family-related move, the educational-related move, or in this case of this graph, a work-related move. And this is showing how precipitation exposures drive work-related migration. So the same kind of idea, where below average precipitation is reducing migration and keeping people in place. I should note, though, even though this is showing the effects of precipitation, we do find that temperature effects additionally impact education and family-related moves. So again, indicating that there are multiple pathways, and it's not just an economic or a labor factor that is driving migration patterns. So a couple conclusions. First, we show that low precipitation and high temperatures are reducing internal migration. Second, we find very similar effects for short and long distance, so that adjacent versus non-adjacent moves. Third, we find that labor migration is strongly impacted by climate variability, but again, those temperature effects show that education and family-related moves are impacting internal migration patterns. And just for the sake of time today, we also looked at climate effects based on individual countries and demographic groups of interest. So we compare educational attainment, so looking at individuals of higher educational attainment versus primary, We also looked at differences between sex, and we also looked at age. So our minimum age is 15, and the maximum age is 49 years old. And we find that age of an individual, specifically older individuals, are most sensitive to climate effects and their response to migration. So limitations, our data misses short duration moves, so we use that 5-year interval reference, and it very well could be possible that people have moved within 1 or 2 years of the census date, and we also don't account for individuals that moved within the same province, referring to very minimal differences between adjacent and non-adjacent moves. It's probably a really good idea for future studies to continue looking at international migration, as we didn't find super big effects between adjacent and non-adjacent moves. Our analysis only accounts for some forms of spatial heterogeneity. And with the use of census, there's a possibility that we were not able to account for marginalized populations that may live in more remote areas and are not as easily or accurately reported in surveys. And we also don't examine for mechanisms such as agriculture, health, and economic activity that may be influencing migration patterns. So next steps, there needs to be more research on climate-induced immobility, so seeing why climate variation is keeping people in place, those trapped populations. Continued studies on links across the economic development spectrum, as our study focuses on low economic countries in Asia, but there's quite a lot of value of looking at developed and higher income countries, and just overall continued research in the population environment field to better predict, to address, and to better support populations that are choosing or are forced to stay in place during these adverse environmental conditions. Thank you, and I will now open up for feedback.